was like 60 degrees the other day. Well, I guess I'm not going fishing. Hi everybody, welcome back to the channel. What we have here is a Pelican 1520 case. I don't know where I got it. Hopefully it's not stolen. But this is a waterproof case that should easily hold these two batteries. There's all kinds of videos out there, people making their own small boxes for trolling motors or for onboard accessories like fish finders and stuff like that. So the thing that I'm trying to build here is a little bit different. One case, one trip, back and forth from the car to the boat when I'm loading in, two different power sources. The 100 amp hour battery is going to be used predominantly for the trolling motor, and the 20 amp hour battery is going to be used for onboard accessories and stuff like that. A functional, portable, waterproof, hopefully floating, dual power supply power pack. Let's get into it. The best place to start is getting the dimensions of the 1520. I took the time to get some measurements off of it, and this kind of works out to be the template. The inside dimensions of this Pelican 1520 per the manufacturer spec are 18.06 inches from this side to this side, 12.89 inches from this side to this side, and 6.2 or 6.72 inches in depth. One of the things that you got to think about if you're specifically going to use the 1520 case is choosing batteries that have dimensions that meet these requirements. The 20 amp hour battery that I picked up, and there'll be a link for this in the description below, it'll fit standing up straight. The 100 amp hour battery, it'll also fit. You have to turn it on its side. It's not going to be where the posts are pointing upward. It's going to be where the posts are pointing towards the handle. The nice thing about lithium ion batteries, they're not orientation specific. If you're going to do this, it has to be a lithium ion battery, and of course you're going to adjust the specifications to whatever battery you happen to choose to buy. All right, so we've already got a rough layout. The amped up battery, right, we're looking when it's laying on its side with the posts in this direction. We've got about 12 inches from left to right, about 8.5 inches from front to back. That definitely fits inside the case. We also have room for a 50 amp circuit breaker, and here's the position where our 20 amp hour battery is going to be. Highly recommend, if you're going to get into doing these kind of projects, you can use SketchUp, you can use whatever online drafting software you can get your hands on, but to my mind, nothing beats a plain old piece of graph paper. So each square represents a 1/2 inch by 1/2 inch side, and you can really easily estimate where things are going to need to go. Remember, this is a three-dimensional object, right? So we've got more space that we can take advantage of. Oriented this way, you can see that we have more than enough space to place the access points for our trolling motor and accessories underneath where that circuit breaker goes. This is your standard big box pink rigid insulation. It's about 1 inch thick. We are going to shape these, cut chunks out of it to allow for our components to actually fit in, and then we're going to stack these within the box so that you get one solid unit of insulation that doesn't interfere with any of your electronics, and increases the buoyancy of the case itself, hopefully. If you stick with the standard foam insulation that comes with a Pelican case, it's real spongy, very, very soft. I'm not sure that I would entirely trust that to hold something as heavy as a lithium ion battery. This is going to do a much better job for us. Okay, so first step, get the first chunk of this down into this box so that we can look at our initial layout and make our first cuts. And this does not have to be super pretty. Make sure that fits snugly. It doesn't have to be crazy tight, and it's okay if you have to compress it a little bit to get it to go down into the box. That's not a bad thing. You want some degree of tension in here because that's going to be what keeps it stable. All right, the next step is to move on to the rough layout. Now, this is the bottom layer that we're working with within the case. Every piece of foam board that we put in is going to have a cutout for the 20 amp battery and a cutout for the 100 amp hour battery. It kind of acts like a placeholder inside of the case to keep everything stable and so it doesn't wiggle around. Ideally, you're going to want about 1/2 inch of foam material, maybe more if you can pull it off, all the way around each of the batteries. It's critical that your orientation for this step is correct. This battery is on its side. The lugs are in the up position, facing what will be the handle of the case. We now have a template for all of the other cuts that we need to make on the remaining 4 sheets of the foam. For this piece, we have to remember this is where our ports are going to go. So all we're using here are these Atwood trolling motor receptacles. So now we're going to go ahead and we're going to drill our first 2 holes in this case. The next step is to hit these up with a little bit of silicone. Fabricate this last chunk of wire, ring connector to ring connector, and then we should have a working box. truth. Both my voltmeters are working. Both turn on and off. All right. I'll grab this for DC 20. .62. .55. It works. It works. Mark these now before we forget. This is my 100 amp hour. This is my 20 amp hour. This is the 20 for accessories, and this one's going to be trolling motor. All right, what do I have that I could potentially charge? I'm going to see if I can charge this GoPro. We're good there. Oh, it's the wrong kind of cable. Oh. All right, we have a known good cable. 13.7. Give me a light. Oh, look at that. It's working. Now, see if it turns off. Yep. So, if this is off, then no power comes out. Try the other one. Yep. Fantastic. All right. Okay. I am excited. So this thing is now completely functional. I'm not sure how much it weighs. If I had to guess, I'd probably say 65 pounds. But can I lift it? Yeah. That's a two-hander for sure. In the next segment, we'll talk about how to make your recharger fit to this so I never have to open this again. Super cool. Super cool. We're not done yet. So now that we have managed to put lightning in the box, we have to figure out a way to replenish that lightning. And that can be a real hassle if you have to have, specific ends for specific batteries. I don't want to have to deal with that. I only want to open it up if I absolutely have to. The way we're going to do that is by modifying our charger so that we can hook directly up to it. What we have here is a NOCO Genius. I think it's designed actually for like living on a boat, like a bass boat or otherwise. It has a dual charger system, and you'll notice that it is rated for 5 amps, right? This is going to be a relatively slow charger. That's fine though. Low power may be a good thing. If you have to plug into somebody's transformer on the back of their car, lower power, while it is a little bit slower, isn't always going to cause a circuit breaker to trip. All we're going to do is cut these positive and negative leads off and replace them with these trolling motor connectors. One of the issues that we do have here is that this is thinner, probably like 12 gauge wire going into an 8 gauge coupler. I'm going to bend these leads over, and that gives me a little bit more material for that connector to grab onto. Crimp connector, good set of crimpers, making sure your heat shrink's already on there. Red to red and black to black. Now we hit them with the heat gun. Okay, so we've got power applied. Let's grab our first connector. One of the things I wanted to point out is when I oriented these vertically, I did that on purpose. If you have to have two connectors that are this close together, and you want to be able to have two things connected to them all the time, if these are turned sideways, there's no way they can be that close. So that vertical as opposed to horizontal orientation is absolutely key to making sure that everything works the way that it's supposed to. These are both auto detecting, automatically brought all of it up. Charge is running. And let's check our voltage reads. 13.8 and 14 volts. So I can set this off to the side, get these banks up to 100%, get ready to head out on the water soon. I am really looking forward to getting this thing out on my brand new kayak. It's a Old Town Autopilot 136. It seems like it's going to be a great boat. It's going to be the right boat for me. I really hope you've enjoyed this and maybe learned as much as I have. Make sure to like and subscribe if you're interested in finding out what I do with this here battery pack. And remember, it's never too late to Kayak.